Okay, now we're going to do an estimation of the area under the curve using the midpoint. So we're given the curve f of x equals 1 over 1 plus x squared, restricting our domain from -2 to +2. We're asked to find the midpoint estimation for the area under the curve using exactly n equal 4 rectangles. So let's enumerate our steps. Step 1, we're going to let the initial x value equal -2, the final x value equal +2. Then the width will be satisfied with the formula w sub I equals x final minus x initial over the number of rectangles n. So that implies that w sub I equals 2 minus a -2 over 4, which is 4 over 4, which implies the width w sub I is going to be equal to 1 for all of our rectangles. Step 2, we're going to do a sketch. Okay, now let's do this. First, let's evaluate f at -2. That's the left endpoint for the x values. That'll give us the y partner 1/5. Now let's evaluate f at the right endpoint. F of 2 equals positive 1/5. So it looks like our left and our right height will be the same. At 0, f of 0 is evaluated as 1 over 1 plus 0 equals 1. And that gives us this what's called a bell curve. So let's label our x-axis, label our y-axis, plot our points. Here's the left point, the right point, and the top point. And here's our little bell curve. And let's see, we have 4 different rectangles here. So we bust this up into 4 pieces. Here we have the midpoint x sub 1 I equals -3/2. I use the w sub I formula to figure out the width. And then the midpoint x sub 2 star equals -1/2. And then this is the midpoint of the interval, okay? And the next one happens at 1/2, and the last one in the interval from 1 to 2, the midpoint is 3/2. And you get that by just dividing the distance between 1 and 2 in half and then locating the position of the midpoint. Okay, so we used x sub I star equals 1/2 times x sub I minus 1 plus x sub I. It's just an average to find the midpoints, what you expect. So let's shade in our rectangles, each of our 4 rectangles. Okay, you have to imagine I did exactly the same width in between. I'm not always using a ruler. A sub 1, A sub 2, A sub 3, and A sub 4. Okay, step 3. We're going to sum. Well, first of all, notice that f of x here is equal to 1 over 1 plus x squared because that was given to us. The sum will be over all the rectangles, and that will give us the area under the curve approximately equal to a sub 1 plus a sub 2 plus a sub 3 plus a sub 4. And that's approximately equal to length times width for the first, length times width for the second, length times width, length times width. And that's equal to the function evaluated at the midpoint, -3/2 times the width. Remember, w sub I is always equal to 1, so it's 1, plus the function evaluated at the next midpoint times the width 1, plus the function evaluated at the third endpoint times the width 1, and then the function evaluated at the last midpoint with the width 1. So actually evaluate the function with f of x equals 1 over 1 plus x squared, and you get these strange fractions times 1. Okay, and one more. Do the multiplication and simplify. We're going to get 4/13. Oh, I want you to notice that we're using that f of x when we do this evaluation. Okay, so simplifying, we get 4 over 13 plus 5 over 4 plus 4 over 5 plus 4 over 13. We have to get a common denominator, so it'll be 65. So it's 9 over 65 plus 52 over 65 plus 52 over 65 plus 9 over 65. Add those together, you get 122 over 65. That is our estimated area under the curve using the midpoints and using only 4 rectangles. We didn't take a limit to let the number of rectangles go to infinitely many and have complete accuracy. We just did 4 rectangles to get a rough idea.